scientifically validated tool to measure antioxidants. So, over the last 25 years, all this knowledge is now culminating in our ability to create and develop this age-lock approach to anti-aging. We are now able, for the first time in the history of anti-aging product development, to be able to really look into the fundamental sources of aging. And we now know that these fundamental sources of aging are actually found at the genetic level. There are three questions we answer with age-lock. Historically, these are the three questions that drove us to create and develop age-lock. The first question is, why is it that some people look younger than they really are? We believe we found the answer. Second question, this so-called the mapping of the human genome in 2003, how is that going to help us to really look at the genetic level? Have we really been able to discover and be able to identify all the genes that exist in the body? I believe we have found the answer. The human genome, we now know, consists of approximately about 25,000 genes. And then finally, out of this 25,000 genes is a huge library. How are you going to find the right book that actually tells you those age-related genes? How are you going to look at those 25,000 genes in a clever way and in a very quick way to be able to home in on those genes that are directly and specifically related to aging? We found the answer once again with age-lock. So, and the first clue that we had came from this particular study of twins. And if you look at this pair of twins, I think you would agree with me that the twin on the right looks far older than her twin on the left. And now we know the reason for that is not because the genes are different. They are identical twins, therefore they have identical genes. The difference lies in the fact that how these genes are expressed controls how you age. And that's what those two pictures show at the bottom. That there is a marked difference, a dramatic difference between the gene expression profile of the twin on the right versus the gene expression profile of the twin on the left. And that is the difference. And that was the first clue that tells us that age-lock is going to work and we are looking at the right place. Where is this right place? I mentioned the human genome. I mentioned we have 25,000 genes now. Consider for a moment that each gene represents a single page of this life's instruction manual of how to create a human being. Okay? Consider that. One gene, one page. Therefore, 25,000 genes equate 25,000 pages of this instruction manual. If you want to go with the traditional way of finding the age-related genes, you literally have to read each page at a time before you reach those genes that are relevant in the aging process. That will take you a lifetime. In fact, it will take my lifetime and my children's lifetime before we can read all 25,000 genes. The key in age-lock, therefore, is now related to the fact and to the discovery that we have, in a way, created the index to the book. Now, with age-lock approach and technology, we're able to go to this exclusive and proprietary index and says to it, show me where those age-related genes are. And we can go to the instruction manual immediately to the page or immediately to those genes that are directly relevant. We don't have to read the whole book anymore. This is the power of age-lock. If you don't believe me, consider for a moment. If I ask all of you to go back during the 2-hour break to go and search genes, what would you do? You would go and Google. And why do you Google instead of using another search engine to search the internet for the word genes? The reason is because we all have become highly comfortable with the power of Google to give you accurate and, more importantly, extremely rapid answers to your question about genes. Similarly, what we have done with this ageLOC is to create this biological search engine that can give us and help us to identify the age-related genes. So, and we didn't get here on our own. We're pretty good, but we're not that good. So, therefore, we had, over the years, sort of always continue to search for academic collaborators. And we have in ageLOC 2 of the most powerful academic research centers related to aging. Okay. The first one is LifeGen Technologies, located out in Wisconsin. And those 2 co-founders have spent the last 30 years studying aging. And they have brought to us incredible insights how and what those genes are that control and regulate the aging process. The second collaboration that we have relates to our relationship with Stanford University. And those researchers are bringing to us fundamental insights how skin ages. So, with this combination, what we have in ageLOC is really our in-house scientists together with the academic insights from those 2 research institutes. We have created ageLOC, and ageLOC continues to grow. Science doesn't stop. Science is not a static process. Your question immediately would be, well, can a competitor compete? Can a competitor duplicate what we do in ageLOC? Yes, after 30 years. Because it took us 30 years to reach this stage. Thank you. So they have to spend literally from day 1 to day, they wish to duplicate an